Hey everyone! In this video, we're doing lesson 4.3, which is solving by elimination. It's the next method out of 4 that we're going to learn. And so this one, we use elimination when we don't have one of the equations already as x equals or y equals. So if you look, all of these examples have the x stacked on each other and then the y's, and then it's set equal to some number. And that is how it has to be set up for elimination. So once they're lined up, you're next going to look at your equations and you're going to look at the variables. So look in front of the x's, look in front of the y's, and see if you have opposite coefficients. So like positive 7, negative 7, positive 14, negative 14. So a positive and a negative of the same number. And so if we look at number 1, in front of the y's, we have a positive 10 and a negative 10. So that is our goal to get those opposite coefficients. So if we have those opposite coefficients, then what we do is we add straight down. So negative 6x plus 4x is negative 2x. Now the 10 and negative 10, it makes 0. So those cancel out. So they're eliminated. That's why it's called elimination. And then negative 14 plus 6 is negative 8. And then we can solve by dividing both sides by negative 2 to get x equals 4. Once we have one of the variables, we have to plug that back in to one of the other equations. So pick one of your equations, it doesn't matter. I'll pick the second one because the numbers look smaller. 4x minus 10y equals 6. And now I'm going to plug in that x, which I found was 4. So 16 minus 10y equals 6. And so then I want to subtract 16 from both sides. That gives me negative 10y equals negative 10. And so then when I divide both sides by negative 10, we get y equals 1. So my solution is the point 4, 1. Number 2. So look at your variables and see if you have those opposite coefficients. And we do. The y's, if I look in front of the y's, I have a negative 2 and a positive 2. So those y's will get eliminated. And then I just add straight down. 7x plus 2x, 9x. Negative 1 plus negative 26, negative 27. And then we divide both sides by 9 to get x equals negative 3. Now we have to go back and find y. So the way we do this is by plugging into either equation. I'll just pick the first one. 7x minus 2y equals negative 1. I found that x was -3. So I replaced the x with -3. Then this turns into -21 minus 2y equals -1. And then I can add 21 to both sides to get -2y equals 20. And then dividing by -2 gives me y equals -10. So my solution is the point -3, -10. Number 3. When I look at my variables, you probably think, oh, the x's, those are going to cancel out. But the x's aren't opposite. They're both positive. And I have to have one of them negative. If I look at the y's, those don't cancel either. So now we're going to have to look at the next step in our directions or our instructions to see what we do next if they're not already opposite. What we do is we multiply one of the equations by something. And if I want to turn this 2 into a -2, I can multiply everything by -1. So if I multiply, and you have to multiply everything. So if I do everything by -1, this becomes a -2x minus 9y equals a positive 26. So I'm just going to cross this one out. And then that gives me these opposite coefficients. So the 2x and the -2x cancel out. So when I add straight down, I get -14y equals 28. And then I divide both sides by -14 to get y equals -2. So I have my y, I now need to find my x. And I can do that by going back to either of my equations. 2x minus 5y equals 2. Be careful because this time I was given the y. Make sure you plug it into the right spot. So 2x, that becomes plus 10 because -5 times -2 is positive 10 equals 2. Then I subtract 10 from both sides to get 2x equals -8. And then dividing by 2 gives me x equals -4. My solution is the point -4, -2. When you're writing a point, you always put the x first and then the y. All right, number 4. So when we're looking at our coefficients, we don't have the opposite coefficients that we need. So we're going to have to multiply something. If you look at your x's, it would be really easy for us to turn this negative 6 into a negative 12? I could just multiply by 2. So when I multiply by 2, that becomes negative 12x minus 10y equals 28. Remember, you have to multiply everything by 2. So now I have a positive 12x and a negative 12x that will cancel. And then I add straight down. 9 minus 10 is negative 1y equals 10. Negative 18 plus 28 is 10. And so then if I divide both sides by negative 1, I get y equals negative 10. And I have to go back and plug into either equation. It doesn't matter. 12x plus 9y equals negative 18. So I know that my y is negative 10. So I'm going to replace the y with negative 10. That's 12x minus 90 equals negative 18. And then if I add 90 to both sides, we get 12x equals 72. And then when I divide by 12, we get x equals 6. So my solution is the point 6, negative 10. Number 5. So on this one, if I look at my x's, I have a negative 10 and a positive 5. If I were to multiply this bottom one by 2, I'm going to get a 10x. So negative 10 and 10, there's some opposite coefficients. Then I have plus 8y equals negative 8. All right, so my x's, I have negative 10 and 10. Those cancel. My y's, negative 8 and 8. Uh-oh, those cancel too. Equals 8 minus 8. Oh, that's 0. That cancels too. When everything cancels like this, it's infinite solutions. So that's when everything, all three things cancel. It's infinite solutions. All right, and number 6, let's do one more. So we want opposite coefficients. So if we look at the x's, negative 8, I want that to turn into a positive 16. So I'm going to multiply by negative 2. So negative 8 times negative 2 is 16x plus 14y equals negative 34. So my x's, negative 16 and positive 16, that's going to cancel. Uh-oh. The y's, negative 14 and 14, that cancels. But over here, 20 and negative 34 is negative 14. So essentially we have 0 equals negative 14. In this one, only the variables canceled out. So if that happens, it's no solution. All right, that is all the examples I'm going to do. I'm actually going to skip the applications. That's not going to show up on your test, so I'm not going to go through those examples. If you have any questions,